Okay, welcome to the SAT Math. This is video 3, and let's go right to it. Here we have a question. It says the graph of the function f in the xy plane. And remember, the xy plane is just a Cartesian grid, or the coordinate plane as they say through high school. And we're saying it's a parabola. We can see the parabola here. What equation defines f? Okay, now when you see stuff like this, they want it in vertex form, so we should know vertex form. So in vertex form, we have f of x equals a x minus h squared plus k. And vertex form is great because it shows us the vertex, right? This would be the x part of the vertex, and that'll be the y part of the vertex, just for a shortcut. So let's look at this. Here it is. Here's our vertex. They give it to us right away. It's a minimum. This is a positive parabola. It looks like a smile. If it looks like a smile, it's a positive. So that means this a right here has to be a positive number. So we can know right now, we can say f of x is going to equal a, and we're going to say x minus 3 squared, and then plus 1, because it's right there. There's the 1, there's the 3. The 3 is the x, the 1 is the y. But we don't need to find the a now. So what we can do is we can use any point. We can use this point or the other point. It doesn't matter. We can use that point to find a. So we have here the y. The f of x is the y is 5, so we're going to say 5. And we're trying to find a. So it's going to be a, and the x is 4. You see it right here. 4 minus 3 squared plus 1. So we can minus the 1 on both sides. And now we have 4. And 4 is going to equal a. And 4 minus 3 is 1. 1 squared is just 1. So 4 is a. Right? And so now our equation then that defines f would be f of x. Well, let's bring it over here. Let's bring it on top here. It'll be f of x. Right? It's going to equal a. No, excuse me, 4. Because we said 4 is a, x minus 3 squared plus 1. So that's the equation that defines f. I'll hold that there for a minute, and let's go on to the next problem. Close that out. Go to the next problem 2. Okay. So triangle PQR has a right angle, and it has a right angle which is Q. So right away, we know that here's the right angle. The right angle is the 90-degree angle. There's Q. And if sine r is 4/5, what is the value of tan p? So we have 4/5. Remember, sine is opposite over hypotenuse, so we know that the hypotenuse is 5. We have a 4. That means we have to have a 3, 4, 5 triangle. That is the common Pythagorean triple, 3, 4, 5. You can use that triple to get any other triples just by multiplying the same number. Like we can have 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. Just created another triple. All right, let's just erase that. And so on. So we know we have a 3, 4, 5 triangle. So let's put, and we're saying R is 4, 5. So let's bring it over here. We'll make this R because opposite is 4, hypotenuse is 5. Remember your ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tan is going to be opposite over adjacent. And you probably remember SOHCAHTOA early on in high school. So we're saying sine r, right here's r, and the opposite is 4, and the hypotenuse is 5, so this will be p. Tan p then, we said, is opposite, which is 3. The opposite of that angle is 3, and the adjacent is 4, so that'll be the answer for tan p. All right. Clear that out, rewind the tape if you need to, and we'll go on to the next problem. All right, so in this problem here, we have in the figure above, we have 2 parallel lines, and they give us the degrees. So let's put that down. We're saying that y is 20 degrees, so there's our 20. We're saying z right here is 60, and let's find x. So remember, when you have 2 parallel lines and it's crossed by a transversal, this line here, this is the line that's cutting the 2 parallel lines is the transversal, you have interior angles now. And you should remember that alternate interior angles, let's say this angle right here, we'll call it A, A and Y will be congruent. They'll be the same. So if Y is 20, that means A has to be 20. A is 20. And if A is 20, this degree right here is 20 because they're vertical angles. So remember your verticals. They're vertical, so they're congruent. Alternate interior angles are congruent. So now we have 60 and 20, which is 80. And you know that triangle is 180 degrees. So X has to be 100 degrees. 100, 20, and 60, 180. So go over your angle measurements. Let me show you another one. Let's clear that out. And I'll give you another example on that. Okay, so if I had, bring page marker back, let's just make some parallel lines. I have a line here and a line there, and then we're cutting it with a transversal. So remember, vertical angles like A and B are vertical, so they'll be congruent. B and C, if I make that C, they're alternate interior angles, they'll be congruent. And D is, again, vertical angle to C, so they're all the same angle. And A and D, by the way, are exterior angles. They're alternate exterior angles. They will be congruent. Something to remember. Okay, let's go on to the next question. We did 3, and we're now at 4. X plus 1 equals 2 divided by x plus 1. What is the value for x plus 1? Okay, so let's pause the tape for a minute. Okay, and get the marker. Let's lift that back up. And we'll get let's use a different color. Use blue. So when you're seeing this, let's just rewrite it now. It's just x plus 1 over 1 equals 2x plus 1. And you can cross multiply. Cross multiply over here and cross multiply over there. You have a proportion, right? So you can just have x plus 1 squared equals 2. And whenever you are trying to get rid of the square, you square root it. But you have to, whatever you do to one side, you have to do to the other. So the square root of x plus 1 squared is just x plus 1 equals the square root of 2. So that's just the answer. Because what is the value of x plus 1? The square root of 2. Okay, clear that out. And we'll go on to the next problem. All right, and this one, we'll do a few of these. This is getting the area of the sector and the segment. So let me just, first we'll get what the sector means. The sector is the central angle. So we'll put that as 0. This is, and R is there. So this is the center of the circle, and you have a central angle. So this whole thing here, all this is the central angle. That's a slice of pizza. We talked about these in the circle videos. So the arc, and this is the arc length, if you remember the arc length. So this is also, the central angle will be the sector. And we're trying to find the area of the sector. And then we'll find the area of the segment. So a segment could be a piece of it. And we'll talk about that in a minute. So let's say that we have theta, and you're going to see that's the Greek letter theta right there. So let's say theta was 80 degrees. So we'll just say 80 degrees. And let's say we know that the radius was 12. So it's 12 everywhere because remember the radius is half the diameter, so it'll be 12 everywhere if we just keep making lines. I can make lines all the way to the end of the circle from the center, and they'll all be 12. All right, so again, this is 80, and we have the radius of 12. How could we get what the area of the sector is? Well, we know the area of the circle, right, is 360 degrees. So the area of the sector is going to be theta, in this case 80 degrees, over 360. And we're going to times it by the formula to get area of the circle, which you should know, pi r squared. And you've probably been doing that even in middle school. So just look at that for a minute. We know theta already, so let's change the color. We know theta already. And it's 80 over 360 times pi r squared. And you have pi on your calculator, right? So don't put 3.14, just press the pi symbol, right? And so let's clean this up now. We'll do it over here. We'll get another color. You can reduce. Always try to reduce. So 80 over 360 is just 2/9 when you reduce it. So it's 2/9 times pi, and r squared is 12 squared is 144. And that'll give you the sector length. So that'll give you about, just say about right now, 100.5 unit. Remember, area is always squared, and that's just units squared. 100.5 units squared about. Just doing the formula, that's it. So we got the sector. I'll leave that up for a minute. All right. Close that out. So now let's say what happens if I already gave you the area. All right, so let's say I put in that the area was already given. Let's say this area was already 50, and let's just say units squared. It's already 50 units squared. And let's say the radius was 8. So clear that. Let's close that out for a minute. Okay, so again, let's put that back on there. I was trying to find a better color. So let's say, again, they gave us the area of that sector was 50, and we're trying to find what theta is. What is the degree of theta? So again, we just do the same formula. We have area, but we know the area already. It's 50. The area is 50. Theta over 360. It's always, remember, circles of 360, pi r squared. So we have that already. Now we need a radius. So let's just say the radius is 8. So now we can do more. So we're going to say 50 equals theta. You don't care if it's theta or x. It's just a fancy Greek letter. And then we're going to say pi, using your pi button. R squared is 64, so we have that already. Okay. So now it's just doing algebra. Just doing simple algebra. If you do 64 times pi, so we'll have it over here, we'll have 50. And let's just do roughly, because you'll get 201. Let's just say 201.06. It's roughly around that. If you looked on your calculator, you would get more numbers. You would get like 192 and so forth. Theta over the whole thing over 360. So if you divide that out on your calculator, you should get a roughly 50. I'm bringing it over here. 50 equals 0.558 theta, and just divide out 558. Whatever you do to one side, do to the other. That'll give us a theta of about, we'll say about 89 degrees. So I know these could be a little complicated, but just rewind the tape. I'll leave that up for a minute. All right, we'll clear it and we'll go on to the next problem. All right, so let's look at this one. A segment now. Let's just get a better circle there. Actually, a better triangle. Bring up the thing again. So what we can do, let's just create let's say that this is the triangle here, right there. Let's just say that. And we're going to create a segment. So if we cut this into a triangle, make a triangle, this area right here is the segment. All right, so if I make another triangle circle, we'll make let's clear it out again. So here's the triangle. Ignore that other one. And we have the central angle right here. And let's just say that theta was 120. So this is 120 degrees. We'll say it's 120 degrees. And we're creating a triangle. And again, the area in here, put it in green. The area in here, right here, is the segment. So how can we find the area of the segment? Well, when you're trying to find the area of the segment, first get the area of the sector. Remember, the sector is the central angle. So what we have here, remember the area of a circle, the area is pi r squared, right? And we'll just get another circle color here. So we have the area, it's going to be 120, because that's the degree, over 360, because the sector is 120 over 360. 360 is the total degrees of a triangle. And remember, we can reduce that, get rid of those zeros. You have 12 over 12 over 36, which is really just 1/3. Reduce it. So we will have 1/3 pi r squared. The only thing now is we just need to know what the radius is. Let's say it's 4. So we can say 1/3 pi 16, or 16 pi. So that's the area of the sector. But let's get the segment now. We got to get a piece of it. Whatever, we're going to take this, by the way. We're going to take that answer, and we're going to minus whatever the segment is, and we'll get the area, right? So let's do this one at a time first. So we know this is the area of, and again, just plug this into your calculator, you get a number, but that is the area of the sector. Sector, not segment. Segment is this green shaded area right here. So let's get the segment. So to get the segment, we have our triangle. So let's just make a triangle here. And we know that it's 120. This is 120. And if we cut it in half, we're going to cut the triangle in half. And then we'll have 60 and 60. We'll have 60 here, 60 there as far as the degrees, 60 and 60. And then if we cut it in half, we also have a right triangle. So now you should know this is a special triangle. When you see these questions on the SAT, there'll be special triangles. So you should know the special triangles are the 30, the 60, and the 90. That's a special triangle. So remember the 30, 60, 90. You'll see that a lot when you're getting these segment and sector questions. So let's write it. Let's just draw it over here now. Let's make it over here, cutting this up. And we cut it in half. So we have 60, we have 90, and we have 30. Special triangle. So we're going to just make it like this now. We have a hypotenuse right here. So we said that the 4 was the radius, right? So 4 will be the hypotenuse. And when you have a 30, 60, 90, you should see these ratios, right? So that should be 2, and this is going to be 2 the square root of 3. Just remember, when you see these, when you cut them in half, you're going to have 4, 2, 2 square root of 3, because these two, again, with the Pythagorean theorem, will equal 4. Now we have all this. This is all we need to know. So remember, we cut this in half before, and we had 4 on each side. So we'll try to find this area right here, because if we know the sector, the area of the whole circle plus the area of the triangle, we subtract that and we get the segment, like I said over here. All right, so now we have 2 is the height. 2 is the height, and 2, the square root of 3, would be on each side here. So when you add them together, remember the area of a triangle. The area of a triangle, is looking a little messy, is just base times height divided by 2. Remember that. So let's close this up. All right, so we have right now this. We said that the area of the circle was 1/3, let's bring back the page marker, was 1/3 16 pi. And we're going to subtract it from the area of the triangle. And we'll get the segment. Area of the segment. We have now this triangle. We said it was a special triangle. It was 4 on each side. We cut it in half. We know that this is a 30, 60, 90. Therefore, if that's 4, that has to be 2. This has to be 2 square root of 3. Just try to remember that. So the area of a triangle, again, is half base times height. The base Here's the base. It's 2 radical 3 plus 2 radical 3, which is just 4 radical 3. And the height was 2. Remember, it's just like terms, like 2 radical 3 plus 2 square root of 3. It's just 4 square root of 3. It's like if you had 2x plus 2x, it's just 4x. Same type of thing. So half of 2, you just multiply. Remember, it's commutative. Half of 2 is just 1. So the area is just 4 square root of 3 units squared, right? That's all it is. That's the area of this triangle. So remember, we made the triangle, cut it in half here, and we're trying to find, now to get the segment, we just subtract. So we're going to do, the answer here would be 1/3 16 pi minus the area, which is 4, and that'll give us the area of the segment. Plug it into your calculator. Try to review that. Rewind the tape. I'll hold for a minute before I clear. All right, so let's look at another one. All right, and let's say now we have a proportion or similar triangles. So let's say that B and D, let's say it was 10 units. B and E was 6. And let's say A and C was 12. So we can do proportions here, and we can find A and D and E and C. Actually, we want to find B and A. What is B and A? What is line BA? And what would be line BC? So just doing proportions, we know that line BD is 10. So we can do 10, and let's say we're trying to find BA, right? We don't know what BA is. We'll just call it X. So 10 over X. And let's just find any other numbers that we have. So BD is 10. And let's say we had, well, let's put another, we've got another number here. Let's put that as 8. Now we have DE. Let's say DE is 8. So and AD is 12. So we have all our numbers, right? We're doing 10 for BD, this triangle here, and then the larger triangle we're trying to find. So we just cross multiply. You're going to have 8x equals 120. Right? And then all we have to do is just divide the 8 out on both sides, and that gives us the x, which is 15, but it gives us what BA is. BA, line BA would equal 15. So let's try to find BC now. Let's see how we do BC. Right? Well, let's clear this out. And we'll use another marker, blue. We said BD was 10. This was 6. This was 8. This was 12. We know that this whole thing right here, B and A, is 15. So now we're trying to find B and C. So we have B and E. B and E is 6, but B and C we don't know. Put an X there. Or any letter you want. And then we can use any other things. We know DE is 8, and we have AC is 12. So as long as you have 3 numbers here we can use, and just cross multiply again. Just doing proportions. Equal ratios, right? So we have, here we're going to have 8x equals 72. Divide out the 8, and x equals 9. So BC, line BC, equals 9. Okay. All right, so that's this video. We'll do others, more circle questions in the other videos.